let's calculate some probabilities and use the idea of complement in here somewhere. And what do I mean by that? Suppose we know that the probability of a basketball team to win a game is 70%. Well, then we know that the probability of not winning is 30%. If we are told that the probability of rain tomorrow is 40%, then the probability of not rain is 60%, because everything has to add up to 100%, all the probabilities. Okay, so let's say in this problem that we are going to be discussing, suppose we have 98 light bulbs, 98 light bulbs. And suppose that 10 are of this 98, 10 are defective. 10 are defective. Okay. So what does this mean? That means that 88 light bulbs are good. So we randomly selected 4. We randomly select 4. So let's say there's a box, and you randomly select 1, then another one, then another one, and then another one. And let me just somebody here say without replacement, without replacement. That means that you don't select one and put it back. You just select one and you put it aside. So the first part of this question is asking, what is the probability that all these 4 light bulbs are good, they're working? So part A, probability of all 4 to be good. Okay. So I know that I have total of 98 light bulbs. If 10 are defective, then 88 must be bad. So for the first light bulb, let me change color. For the first light bulb, I have total of 88 good light bulb over the total of 98. So 88 out of 98 are good for the first one that they pick. That's the probability. Now I took one good one out. I have total of 87 good one left and over 97, because now there's one light bulb less in the box. And for the third one, I have total of 86 good divided by 96, 86 out of 96. And finally, for the last one, I have 85 out of 95. And according to my calculator, I get to 4 decimals, I get 0.6455. So there is 64.55%. I'm just multiplying this number by 100. So 64.55% chance that all 4 of them are good. Let's go to part B and figure out the probability that all four to be defective. Okay, so notice that for the first one, for the first pick, I have total of bad ones divided by 98. For the second one now, I have 9 left divided by a total of 97. Then 8 over 96, and then 7 over 95. And if I put that in my calculator, I got 0.0001. And if I multiply that by 100, I get 0.01%. So there's 1% of a percent chance for all 4 of them to be defective. All right. Let's go to part C. Part C is interesting. Part C is telling us what is the probability that at least, this is the key, at least 1 to be defective, 1 to be defective. Okay, so here you probably think to yourself that if I could figure out at least 1 defective could be probability of 1 light, one of them to be bad, probability of 2 of them to be bad, probability of 3 of them, or all 4 of them. And if I figured out all that and add them together, then I have figured out the probability of at least 1 to be bad. But there's an easier way. We can use the complement. So we can use the fact that 1, which is also same as 100%, minus the probability of all of them to be good, okay, gives me the probability of at least 1 to be defective. So 1 minus, and I already have the probability of all good was figured out, calculated in part A, 0.6455, okay? And that equals 0.3545 or 35.45% chance that at least 1 of them to be defective. So once again, you could, but I don't recommend it, say P of 1 defective plus P of 2 defective plus P of 3 defective plus P of 4 defective. That should give you the same number. That should give you the same calculation, but it's just longer. And when you take your exam, you're not going to have that much time to do things the long way. Okay, one last part is what is, let's say, the probability that at least 1 is good. So this was part D. Let me just go to part D. Probability that at least one is good. So once again, the long way would be that for you to figure out the long way. So let me put here long way would be for you to say P of 1 good plus P of 2 good. Let me just rewrite this. Let me put this P of 1 good plus probability of 2 good plus P of 3 good plus P of 4 good on the 4, That would be the long way. I don't recommend that at all. So the smart way of doing this is to say, okay, there is 1 or 100% probability minus probability of all of them to be defective, the complement of this. Okay, so 1 minus, and this we figured out in part B of the problem, 0.0001. So that gives me 0.9999. All right, if you want to multiply that by 100, I get 99.99% chance that at least 1 light bulb is going to be good. Okay, I hope you enjoyed this example. Thanks.